All right, let's take a look at number 5. It says the balloon is rising vertically above a level straight road. So we got a straight road here, and our balloon starts off down here, and it's rising. At a constant rate of 1 foot per second. So that's our vertical distance there. So dy dt is 1 foot per second. Just when the balloon is at 65 feet above the ground, a bicycle passes under it going 17 feet per second. So it starts off at 65 feet. Bike is right here. So it's 65 feet above the ground. The bike starts off right underneath it. And it's going 17 feet per second. It asks how fast is the distance between the bicycle and the balloon increasing 3 seconds later. So bike starts here. 3 seconds later, it's going to be past the balloon. After 3 seconds, going 17 feet per second, the bike is going to be over here. There we go, our lovely little drawing. Our bike's going to be over here. We're trying to figure out how fast is this distance between them changing. So we're going to make that z. And then x is our horizontal distance. So our horizontal distance, if the biker rides for 3 seconds at 17 feet per second, x is going to be 51 feet. 3 times 17. Now be careful, this height of the balloon is not just 65. Remember, it started at 65, then 3 seconds later, it's not going to be just standing still there. It's moving at 1 foot per second. So it's moved 3 more feet after 3 seconds. This y value is actually going to be 68 feet. Right? Started at 65, moved 1 foot per second for 3 seconds, so it's going to be at 68 feet. So x is 51 feet, y is 68 feet. Z we don't know, but we can figure out using our good old Pythagorean theorem. So this one doesn't come out as nice as, actually it does come out nice. I'll take that back. This is a 3, 4, 5 triangle, but you probably wouldn't recognize that at first. So we can use Pythagorean's theorem, 51 squared plus 68 squared equals z squared. If you add those up, take the square root, you end up getting 85 feet. Well, we know biker is traveling at 17 feet per second. That's going to be our dx dt. That's our horizontal rate of change. What we're trying to figure out is dz dt. How fast is this distance changing as the bike is riding away and the balloon is floating up? So we want to find dz dt. Why don't you guys go ahead and take a few seconds to finish this one off. Let's see if you can do it in a minute. All right, let's go ahead and take a look and see how you did. All right, so you should get 11 feet per second. Take the derivative of both sides with respect to time, substitute the values in that we know, and solve for dz dt.